So we're now going to try out some things related to what are called output buffers. So you can see here, there's a bunch of different outputs that you can get out of this raymarch operator. So the main one is just kind of like the standard camera color output, but there are also a number of other outputs. So this third one here is depth output. So it's a little bit hard to see just given the range of values. So if we were to change the, so we're going to enable the like display pixel values option here. So you can see here, it's got values that are representing like the depth distance from the camera of each point. But because those values are, numbers like 100, they don't actually show up well as, as colors, because it kind of caps out at 1. So there are some operators that you can use to help out with that. So there is this thing called depth map. So you can either connect that output here, or you can drop one of these output operators onto that, and it will grab that depth output. So what this does is it looks at that range and then it scales it down to a smaller range. So you can see here it's scaling down from a range of like 0 to 20 to 0 to 1. And you can clamp that at 0 to 1 if you want, which will mean that like any value that's greater than 1 will just get clamped at that. There's an option here to snapshot range. So what this does is it looks at the input and finds the largest value and the smallest value, and then it will use that as the input range. So if I click that here, you can see that it's found that like the smallest distance is 4.7436, largest distance is 100. And so it scales down to that range. That 100 value is coming from the kind of maximum distance that the renderer kind of caps out at. So that may not be like the most useful range to measure things by. So if you go with kind of a smaller value, so let's go back down to about 20 or so here. And you can use this gamma parameter to kind of change the steepness of the depth curve. So you can use that as a way to kind of go from like a really sharp cutoff to a kind of smoother cutoff. If we change our camera position here, you can see that, yeah, as you get that range, it will show depth from wherever the camera is, so you can get different ranges of values there. It's important to know, especially with when using snapshot range or doing things like moving the camera, that the range of depth values that you could be getting could change potentially by a lot. So if you do anything kind of major to like change the structure of your scene, you may need to adjust these ranges again. One possible use for this is to do something like blurring based on distance. So if let's bring this in a little bit closer here. Change our view angle there. We've got the depth here, so that's going at like kind of a one value of 1 at the furthest distance and a value of 0 at the closest distance. Let's stick another null in between that and this. One useful operator to combine with this depth map is luma blur. So if we take that and the depth map, you can apply different amounts of blur depending on what that depth is. So here you can change, how expensive it is. You can see like the further away it is, the more it's blurring. You can use this for like a depth of field effect. So far we've seen this kind of color, this main color output, and we've seen depth output. So there's also some other ones available. So we're just going to type output select or render select, and it's going to paste in one of these. So this is similar to the render select top, which actually internally uses a render select top. So we drag that onto here. So it's going to show up this buffer or this menu of different kinds of outputs that we can look at. So there's color, which we've seen so far. There's depth that we've seen so far, and then a bunch of other ones. And some of those are kind of useful for rendering, and some of them are kind of more useful for debugging. So we're going to try out the normal output. Stick a null at the end there. All right, and you can see that this is empty. And the reason that it's empty is because you need to enable that kind of output in the renderer. So you can see here, switch on normal output. All right. And now what we've got here is a map of the normals of the surfaces, which is like the direction that that surface is facing. So you can see that, for this face here, this is pointing negative 0.34 in X and so on. So this can be useful for kind of understanding the shape of your scene, but it can also be useful for things like edge detection. So you can say, you can apply edge detection here. And so what this is doing is it's saying basically anywhere that there is a corner where the normal changes sharply, you can create an edge. There can be some kind of rendering artifacts around some of these values. So sometimes it can help to kind of increase sample step, or sometimes apply a little bit of blurring after the edge detection here. So what we can do here is combine this. So I'm going to create a composite top. We're going to take the output of this this first one. I'm going to get rid of the blurring for now. I don't think I want to keep that. And we're going to combine that with the edge here based on the normals. So I'm going to change the operation to lighter color. All right, so you can see here what that's done is you've got that main color, and then you've got the edges of where there are, so you have all the areas where there were kind of corners or sharp edges, and you've got a highlight on those. And you can play around with kind of different effects here and try, subtracting, which gives you this kind of dark look. This kind of gives you a little bit of a kind of cell shading look. I'm going to get rid of this depth map for now, and kind of clean things up a little bit. We've got this chain here that's taking a sphere and a box frame, and it's combining those two shapes with the stair operator. You've got that going into a transform, which is doing a little bit of rotation. It's going into a twist, which is currently disabled. And that's going into an iterated transform that's doing this kind of fractal rotation effect. And that's going into a modulo 1D, which is sort of repeating this infinitely along the x-axis. You've got a camera, which is choosing where the scene is rendered from, and then you have this render operator, which is running that as a shader and producing this output. Now down here, we've got a render select, which is grabbing the normals. And remember, in order to get that to work, we had to go to the settings and the output tab on the render and make sure that that is switched on. And then we are doing some post-processing on the normals to get these edges, and then compositing that with the color output to get the final output. So that is your full scene.